What's poppin', dogs? Mr. Allen here with some solving of trig functions. Some fun stuff here, a little pre-calc action. We got to solve for theta in each, and theta is bound between 0 and 2 pi. So we're in radians for this one here. First one, 3 tangent squared theta minus 1 equals 0. So what can we do here? I've got one trig function here that is squared. If I isolate that, I can square root to continue to solve. So I think I need to get the tangent squared theta by itself. Let's add 1, so I get 3 tangent squared theta equals 1. Divide by 3, and I've got tangent squared theta equals 1/3. How about square root on both sides? That'll do. And now I got tangent of theta equals plus or minus. Square root of 1 is just 1 over root 3. Ooh. All right, so if you're a unit circle person, that's cool, that's cool. I'm more of like a draw triangle kind of guy, all right? So I'm going to draw triangles. So if I draw up my bow tie here, or if you're, into pasta, you're farfalle, okay? So we're going to be in all quadrants here, aren't we? With my farfalle? Yes? Because we're both positive and negative. Tangent is going to be positive here and here, but it's going to be negative here and here. Right? If you don't remember that, all students take calculus. Cool? All right? So that's always good to have in your head. So let's label some triangles here, okay? So we've got our opposite side is 1. Our adjacent side is root 3. That guy's 2 if you're, just having some fun here with your 30, 60, 90 triangles. But that's going to be, let's see here, the angle here, the first one, that's a 30-degree angle or a pi over 6. We are in radians, so I want to do that pi over 6. I'm going to make a little room here. So the first one is going to be pi over 6. My next one here is going to be 5 pi over 6. The next one after that is 7 pi over 6. And the last one, I'm going to run out of room here, is going to be 11 pi. 11 pi over 6. Boom, there's 4 solutions for this one. It exists in all 4 quadrants. Dang. It's a fun one to start out with, man. I kind of like when it's the plus or minus because it's in all 4 quadrants. Makes it kind of easy, right? If it didn't have the plus or minus, it was just positive, we'd be dealing with pi over 6 and 7 pi over 6 because that's the first and the third. And then if it were negative 1 over root 3, you'd be dealing with these two here. Okay? If you're a unit circle person, that's cool, man, but I like triangles with these types of problems, especially when they bring other things in, some Pythagorean triples and stuff like that. So triangles are those are my move, okay? Next one. We got sine squared theta plus sine of theta equals 1. Well, if this were equal to 0, then I could take out a GCF and then use 0 product property, but it's not equal to 0. It's equal to 1. So let's try subtracting 1, because we're dealing with a quadratic here, likely some factoring involved. Right, so if I subtract 1, I got 2 sine squared theta plus sine theta minus 1 equals 0. Now, a little mathematical sidebar here, if you will. I don't have room on the side, so I'm just going to have to write it below it. I'll do it in some lime, yellowish, whatever color. What if I wrote this? 2x squared plus x minus 1 equals 0. That is factoring with a lead coefficient. And if you use guess and check, which I think is probably the best move for you right now, get used to it because doing rainbow method and these and all this, there's so much work. You run out of room. It's got to be 2x and x. It's got to multiply to negative 1 here while adding to positive 1. So I'm thinking I need a positive 1 here so that I get 2x, negative 1 right here, so I get a negative x. That adds up to positive x. So this is factored wonderfully. You could plug your sine back in here. We essentially said that x equals sine of theta. Some might use u, but I'm using a substitution type method here. So you can either plug sine back in now and write the whole thing out, or you could solve each one of these. This 2x minus 1 equals 0 will give you x equals 1/2. This one here will give me x equals negative 1. And now what I can do is I can say, well, sine equals 1/2. Sine of theta, rather, is equal to 1/2. And sine of theta equals negative 1, because x equals sine of theta. Cool? So whether you use x, you use u, whatever, I guess u would have been more proper, right? But I was just doing street math, All right. So let's solve these. Now we're at this point here where we were here, right? It took a little more to get there. Some problems are more difficult than others. Well, sine of theta being 1/2. Sine is positive in the first and in the second quadrant. So if I'm drawing up my farfalle action, we got a triangle here, Here, I'm a 1, I'm a 2 for my opposite and adjacent. This reference here is going to be a pi over 6 or 30-degree reference. So I know that I've got for this one, let me remove some of this, pi over 6. And then the next one here, boom, we are at 5 pi over 6. Cool. Next one there, I guess I can keep it blue. When is sine going to be equal to negative 1? That's quadrantal. Sine is my y-coordinate. When is my y-coordinate negative 1? If I'm looking at my all students take calculus action here, all the way down here is when my y-coordinate is negative 1. So it's going to be at 270, or in this case, 3 pi over 2. So this one's the 3 pi over 2 for theta. There we go. Cool, man. We got 3 solutions for this one. Sine's not going to be negative 1 anywhere else. If when you have them like where they're equal to 0, you end up getting 2 solutions because there's 0 in 2 spots. But otherwise, they're either positive 1 or negative 1 for your quadrantals, okay? For sine and cosine, right? Tangent can be like undefined. Anyway, there we go, guys. That's some solving there without a calculator on these. This would be definitely on the no calculator section, hence why I wasn't busting this bad boy out. But there are times where you are doing these types of things with the calculator. I have another video on that, so be sure to check that one out when you're prepping for your trig solving test. See you guys later.